Hello everyone, so in today's video lecture, we would now be deriving the value of raw balance for doubly reinforced rectangular beams. Okay, so when we say raw, this stands for steel ratio. And when we say steel ratio, this is actually the ratio of our tension steel by the effective concrete, BWD. So that is once again for steel ratio. So when we say BAL here, BAL stands for balanced condition. Okay, so that is for raw bal. So when we say raw balance, that is now the steel ratio that would give you a balanced condition. So when we say balanced condition, guys, so balanced condition, this is basically a condition or a situation wherein the stress that is being experienced by our tension bars, Fs, must be exactly equal to Fy or the yield strength of the steel. So meaning when we say balanced condition, the steel is actually on the brink of yielding, or in other words, it is actually starting to yield already. So from that, guys, when we say balanced condition, Fs must be exactly equal to Fy. So not greater than, not less than, it must be exactly equal to Fy. So previously, when we have solved for the raw balance for SRB, we have actually derived that the raw balance for SRB is equal to 0.85 times F prime C divided by F sub Y times beta 1 times 600 plus 600 plus F sub Y, or we can actually rewrite this as, so raw balance is also equal to 0.85 times F prime C divided by F sub Y times betas of 1 times 0.003 divided by 0.003 plus strain Y. Okay, so you can make use of any of these two equations here, but take note that this is only true for S, R, R, B. Okay, so meaning that we cannot make use of any of this formula actually here. Okay, so proceeding, let us now derive the value for raw balance. Once again, when we say balanced condition, Fs must be equal to Fy. And when we have solved for the raw balance before, what we did was that we have just solved for the summation forces horizontal equal to 0, or that the compression forces must be equal to the tension forces. And looking at this figure on the left here, so looking at the figure here on the left, we now have a new entity here called AS prime. So this is now the area of compression bar. And from that, guys, came a new force called AS prime FS prime. So this force here is the effective force of our compression bar. Okay? So from that, for the forces under compression, so we have, of course, the resultant of our compression block, which is 0.85 F prime C times ABW. So once again, 0.85 times F prime C times A times B sub W. So that is now for the compression concrete. And since we have a new entity here for compression called AS prime FS prime, so we would now be adding them here plus AS prime FS prime. So this is now equal to the total tension force, and according to our stress diagram here, the only tension force here, of course, is ASFS. So this is now equal to ASFS. So AS prime FS prime, once again, this indicates compression, and ASFS, this is now for tension. Okay, so once again, when we say balance condition, our Fs must be equal to Fy. Thus, let us change this Fs into Fy. And if you would now be changing that into Fy, we can now say that the area that we will be solving for here is now our balanced steel area. Okay, so from that, rewriting our equation, 0.85 times F prime C times A times B sub W plus AS prime FS prime. This is now equal to AS balanced times Fy. Okay, so since we are solving for raw balanced, so once again, since we are solving for raw balanced, so let us now change the value or the variable AS balanced into its raw counterpart or raw balanced counterpart. And once again, since raw is equal to AS times B sub WD, we can now say that AS is equal to, so cross-multiplying this equation, so that is now equal to rho times B sub W times D. Okay, so rewriting our equation, this is now equal to 0.85 times F prime C times A times B sub W plus AS prime FS prime. This is now equal to rho balanced times B sub W times D times Fy. Okay, so rewriting this equation to my next slide here, since I do not have any more space. So once again, 0.85 F prime C A times B sub W plus AS prime Fs prime. This is now equal to AS balanced. That is equal to rho balance, I should say. So rho balanced times B sub W times D times F sub Y. Okay. So also, I will be rewriting A in terms of C. So A is actually equal to beta 1 C. Okay, so rewriting our equation now. So 0.85 F prime C times beta 1 C times B sub W plus AS prime Fs prime is now equal to rho balanced B sub W D times Fy. Okay, so since we are solving for the value of rho balance, I will now be deriving our whole equation or both sides of the equation by BWD times Fy in order for this to cancel out. Okay, so divided by B sub W times D times Fy. Okay, so I will also rearrange my equation in such a way that the value for rho balance will now be on the left. So from that, rho balance is now equal to 0.85 times F prime C times beta 1 C times B sub W divided by B sub W times D times Fy plus AS prime divided by BWD Fy Fs prime. So I forgot the Fs prime. Okay, so take note here that BW would simply cancel out. Apologies. So once again, BW would simply cancel out, leaving us at an equation of 0.85 F prime C beta 1 C divided by D Fy plus AS prime Fs prime divided by BWD Fy. Okay, so let me just rewrite that. Okay, so once again, rho balance is now equal to 0.85 F prime C times beta 1 C divided by D times Fy plus AS prime Fs prime divided by BWD times Fy. Okay, so I will now be rewriting the value of C. So for the value of C, looking at this particular stress diagram here, so let me just move the strain diagram, I should say. So I will be removing them here. Okay. So once again, looking at this particular strain diagram, we actually have derived before that C is equal to 0.003 divided by 0.003 plus strain of steel times D. Okay, so this came from similar triangles. Of course, it came from this particular strain diagram. And from that, guys, C can also be rewritten as, if you would now be multiplying this by 200,000, this can now be rewritten as 600 divided by 600 plus Fs times D. Okay, so this is now the value of C. So for C balance, so this is now the value of C under balance condition. This is now equal to, so we would just be changing the value of Fs into Fy. So 600 divided by 600 plus Fy times D. Okay, so for the value of C in this particular equation, once again, this must be C balance because that is now the value of C under balance condition. I will now be changing it in terms of this equation. Okay, so from that, rho balance is now equal to 0.85 times F prime C times beta 1 times C balance, and once again, C balance is now equal to 600 over 600 plus Fy times C balanced. Times D, I should say. Okay, apologies. Okay, so times D. So this is now divided by D times Fy plus AS prime times Fs prime divided by P sub WD times Fy. Okay, so as you can see that D here would now cancel out. Then simplifying this equation further, rho balanced is now equal to 0.85 F prime C divided by Fy times beta 1 times 600 divided by 600 plus Fy plus AS prime divided by BWD times Fs prime over Fy. Okay, so as you can see that this part of our equation here is very familiar. So I think that this is simply the rho balance for SRB. So in order for you to better remember this rho balance for DRB, just add this particular equation from the rho balance for SRB, okay? Also, you can actually rewrite this particular equation here. So as you can see, this is now AS prime divided by BWD. You can actually rewrite this as a rho prime. So from that, guys, we can now conclude that rho balance for DRRB is now equal to 0.85 times F prime C divided by F sub Y times beta 1 times 600 over 600 plus Fy plus rho prime times the ratio of Fs prime divided by Fy. Okay, so this is now the value or the formula for rho balanced for DRRB. Okay, however, we do not know the value of Fs prime. So let me just tell you guys that for rho balanced here, so let me just go back to our equation here. So for rho balanced, since we have indicated earlier that the tension still must yield in order for it to be called rho balanced. So it does not really indicate that our compression burst would also yield. So meaning, guys, that for the value of Fs prime here, so once again for the value of Fs prime here, we do not know if this would yield or not. So from that, just solve for Fs prime. So in our previous video lecture, we have derived that Fs prime is equal to 600 times C minus D prime all over C. And from that, guys, for the value of Fs prime, simply substitute the value of C bal to this particular equation. And if Fs prime is now less than Fy, then meaning use this particular value. But if Fs prime is greater than or equal to Fy, then meaning that for your Fs prime, it must be equal to Fy. Okay, so with that, let us have an example in our next video.